I'm gonna call me Luther. Can you be my tutor? I want to feel like tutor. Can you be my tutor? I want to feel like.
Hello everyone, my name is Benjamin aka Mr. Mushabati and I am your favorite tutor. In today's video, we are beginning the process of solving question 2 from the 2024 Math-1110 tutorial sheet 1. And without wasting much time, let's jump straight into it. So, question 2 reads, in each of the following Venn diagrams shared Roman numeral 1, the set B intersection A minus C complement, and Roman numeral 2, the set B intersection A union C complement. So these are the sets that we have to shade in each and every one of the Venn diagrams, and this is how it's going to work. So for Roman numeral 1, we're going to shade this set in this Venn diagram, and then we're also going to shade it in this Venn diagram. And the set on Roman numeral 2, we are also going to shade it in this Venn diagram first, and then secondly we're going to shade it in this Venn diagram right here. So this is what we are going to be doing today. Let's start with Roman numeral 1. So Roman numeral 1 here says we should shade the set B intersection A minus C. Alright, and we have a complement right there. So this is the set that we need to shade, but in order for us to shade the set in each and every one of these Venn diagrams, we have to simplify it, because like this it's a little bit difficult for us to do so. So when we simplify it, we're going to have B intersection A intersection C complement, and then we're also going to have a complement on the outside. And then when we simplify this further by multiplying the complement here on the outside with everything inside here, the brackets, what we're going to have is B intersection A complement, and then the intersection sign here changes to union, so we're going to have union C. Alright, why C without the complement? Because complement times complement cancels each other out. So we are going to have the set B intersection A complement union C. So this right here is the set that we need to shade in our Venn diagram right here. Okay, so let's do that. So now, whenever you're dealing with questions like this that have to do with shading, it's very important for you to always have a rough paper on the side. What you can do is obviously have your main Venn diagram on your answer sheet, obviously where you're shading, and then have a separate rough paper where you can draw a separate Venn diagram where you can basically do your rough work. And then when you're done finding your answer using the Venn diagram on your rough paper, you can then transfer your final answer to the Venn diagram on your answer sheet. We're going to assume that this Venn diagram here is the Venn diagram on our rough paper rather, and this Venn diagram that we have here on the left, the bigger one, is what's going to be the Venn diagram on our final answer sheet. To begin with, we're going to start by shading the set B intersection A complement union C on the Venn diagram that is on our imaginary rough paper, okay, which is the smaller one on the right hand side. So we're going to use separate colors in order to shade the set B intersection A complement union C on our rough Venn diagram. This will help us just visualize what exactly is going on. So whenever we're dealing with questions like this, it's important to always break them down, because you can't go straight into just shading the set because you do not know how exactly the set looks like. You have to simplify your process, and simplifying your process means breaking down the set. So in this case, we are also going to break down the set B intersection A complement union C. So we're going to first start by shading this part here, A complement union C, and in A complement union C, we are also going to break it down and start just by shading A complement alone. So A complement is basically everything outside the set A. So when we shade A complement here, we're going to have this area right here. So now we've basically shaded the entire A complement. So this is how A complement looks like. It's everything that is outside the set A. Now the next thing that we are going to do here is now include union C, right? Because it's not just A complement alone, but it's A complement union C. So A complement union C just means that we need to include the entire set C to A complement, and that means that everywhere else where we've shaded A complement, we need to also include the shading of the entire set C. Now when we look at set C here, right, you can see that we haven't shaded all of it. We've only shaded part of it. Why? Because the part that we've shaded so far is A complement. So now when we include set C to A complement, what we are going to have is a situation where this unshaded part of set C is also going to be shaded as well. So we are now going to extend these lines here to show that we are also shading, or we are also including set C to A complement. So everything that we now have here is basically A complement union C. Alright, so we're done shading A complement union C. Now the next thing that we need to do here is shade B. Alright, we need to shade the entire set B. So when we shade the entire set B, this is how it's going to look like. Alright, so we are done shading the entire set B, and this is how it looks like. So you can see that all the red lines are basically covering the entire set B. Now, the key thing here is to figure out which part is B intersection A complement union C. When we look at the entire B intersection A complement union C, what we are saying here, or what we mean, is what is common, or what shaded area is common between the set B and the set A complement union C. So we need to find the common shaded area. When we look at our rough work here, when we look at the common shaded area, the common shaded area is going to be the part that has been shaded twice. Okay, so what we are going to see is a situation whereby the shaded area that has been shaded twice has both red lines and blue lines. So when we look at our Venn diagram here, we're going to see that the most common shaded area, or the area that has been shaded twice with a blue line and a red line, is basically the part that I'm highlighting now with the black line. Alright, this area right here is the area that has been shaded twice, right? You can see that in this entire area we have both blue lines and red lines, right? This area here that basically signifies the intersection between set B and set A, you can see that it only has the red line, so it's not going to be included. Rather, the part that has been shaded twice is this area here where we have both blue lines and red lines. So this part that we have identified here that has been shaded twice is what is our B intersection A complement union C. So now this part that we have around here with the black line is what we are going to now transfer to our Venn diagram on our final answer sheet. So it's going to look something like this. So, ladies and gentlemen, the part that we have shaded here on our final answer sheet, or on the Venn diagram on our final answer sheet, is basically our B intersection A complement union C. This is our final answer. Now, for those of you that do not have faith, what we are going to do here is we're just going to come up with an imaginary universal set as well as imaginary elements in all the sets A, B, and C, in order to prove that the part that we've shaded here in our final Venn diagram or in our final answer sheet is basically B intersection A complement union C. Now we are going to illustrate this information that we have here on the Venn diagram that we have below here. Alright, so when we look at our three sets here, what's the most common element throughout the sets? So we'll see that the most common element is 4. Alright, so we're going to have 4 here in the middle. What is common now between the set A and the set B? We'll notice that the only thing that was common was 4, and we've already included it here in the intersection of all three sets. Now let's look for what's common between the set A and the set C. We're going to see that the most common elements here are 2 and 3. So we're going to put 2 here and 3, and then now we're going to look for the most common elements between the set B and the set C. So when we look at this, we'll see that the only element that is common between the set B and the set C is 5. Alright, so 5 is what's going to come here. So now we deal with the elements that go into the independent parts of each and every set that we have here. And which elements are those? So we'll notice how for set A, it's going to be 0 and 1, because 2, 3, and 4 have already gone into the intersection part of all three sets. So we're going to have 0 and 1. And then set B, it's only going to be 6 and 8. Alright, so set B, we're going to have 6 and 8. And then for set C, we are going to have 7 only. 7 is the only element that's going to go into the independent part of set C. And then when we look at our universal set, we'll see that the elements go beyond 8, right? So we also have the element 9 and the element 10. So now this element 9 and this element 10 is what's going to come into the general universal set. So we're going to have our 9 here, and then we're also going to have our 10. So now that we have illustrated this information on this Venn diagram of ours, what we are going to do next is now find the set B intersection A complement union C using the elements that we have here. Okay, so now what's going to happen, in order for us to do this, we first need to find what A complement is. We already know what B is, we already know what the set A is, we already know what the set C is. So let us find A complement. So when we look at A complement is just all the elements that are not in the set A. And set A has 0, 1, 2, 3, 4, which means that A complement is going to be 5, 6, 7, 8, 9, 10. So let's write that down. 5, 6, 7, 8, 9, and 10. So this is our A complement. Now that we have our A complement, let's find the set A complement union C. Let's just combine A complement and the set C. So when we combine them both, we're going to have 2, 3, 4, 5, 6, 7, 8, 9, and element 10. So this is our A complement union C. Now let's look for the element that is common between the set B and the set A complement union C. We know what our A complement union C is, we know what our set B is, so now let's find the most common element. So when we look at set B here, 4 is in the set B, 4 is also in the set A complement union C, so we're going to have 4 there. And then 5 is in the set B, 5 is also in the set A complement union C, so we're also going to have 5 there. And then 6 is in the set B, and 6 is also in the set A complement union C, so we're going to have 6 there. And then what else do we have? Do we have 8 in set B? Yes, we do. How about A complement union C? Yes, we also have 8 there, so we're also going to have 8 in our set here. So B intersection A complement union C is equals to 4, 5, 6, 8. So this is the final answer that we now have. Now, in order for us to prove that the area that we have shaded here in our Venn diagram on top here is really B intersection A complement union C, we are now going to shade the area that has the elements 4, 5, 6, and 8 in the Venn diagram that we have here below. So now let's shade the area that has the elements 4, 5, 6, 8. We can see that 4 is here, 5 is here, 6 is here, 8 is here. So we're going to shade this area right here. Alright, so now we are done shading the area that has the elements 4, 5, 6, and 8. So when we look at the Venn diagram below, the shaded area in the Venn diagram below and the shaded area in the Venn diagram above, we are going to see that this area is one and the same thing. And by doing this, we've actually proved that the area that we shaded here on the Venn diagram on top is actually the set B intersection A complement union C. So now we need to go ahead and shade B intersection A complement union C on this second Venn diagram that I'm basically highlighting roughly here. But before we can actually go ahead to the next part, I just want you guys to take note of something. Like this proving that we have done here below, you don't have to do it whenever you're writing a test or an exam. This is just to help you understand that truly the area that we have shaded here is really B intersection A complement union C. You don't have to do all this rough proving stuff. The only thing that you need to do is maybe do this part that we've done on our rough paperwork, the small Venn diagram, and then transfer your answer from the rough paperwork to your final answer sheet on the Venn diagram on your final answer sheet. That's the only work that you have to do. So no need to do all this complicated stuff that we've done here. This is just to simplify your lives and help you understand that truly the area that we've shaded here is the set B intersection A complement union C. So with that said, let's now move on to the next part of Roman numeral 1. So moving on to the next part of Roman numeral 1, all we now have to do is shade the set B intersection A complement union C on the second Venn diagram that we have here. Alright, and we are going to follow the exact same process as we did with the first part of Roman numeral 1. So the first thing that we're going to do is obviously break down the set B intersection A complement union C, and we're going to first start by shading A complement union C. But before we can actually get to shading the entire A complement union C, we are going to first start by shading A complement alone. So A complement is going to look something like this. So what we have here is basically A complement. This is how A complement looks like. So the next thing that we need to do now is look at the entire A complement union C. So when we say A complement union C, what we are saying is combine C and the entire set A complement. So if we look at our rough Venn diagram over here, we are going to do the exact same thing that we did on the previous part, and that is to basically include the entire C to the shaded area that represents the entire set A complement. And if we look carefully here, set C is not entirely shaded. You can see that there's a small area here that is not yet shaded. So this is what we're going to include to ensure that now we have shaded the set A complement union C. So let's do that. So we're going to shade this area as well, and then we can include a few more lines, okay, to just ensure that we're shading the entire set C. So what we have now is A complement union C. We have shaded the entire set A complement union C. The next thing that we're going to do, like we did in the previous part, is separately shade the entire set B. So let's do that with our red color, and this is how our set B is going to look like after we shade it. So this, ladies and gentlemen, is how our set B looks like after we have shaded it entirely. We now need to look for the most common area, right? Because the set here is B intersection A complement union C. What is common between the set B and the set A complement union C? This is what we are looking for. This is what we want to shade. So if we pay close attention, the area that has both the blue lines and the red lines is this area here that I'm about to highlight here with our black line. So the area that I have highlighted with the black line is the most common shaded area. It's the area that is common between the set B and the set A complement union C. So now we are going to have to transfer this area to our final Venn diagram on our final answer sheet. So when we do that, this is how it's going to look like. So this shaded area that we have here on our final Venn diagram is the area that represents the set B intersection A complement union C. So this is how our B intersection A complement union C is going to look like when we shade it on this type of Venn diagram. Now for the unbelievers out there, we're going to just try and prove that this area that we've shaded here truly represents the set B intersection A complement union C. And we are going to prove this using the elements that we have down here like we did in the previous part. So let's get into it. So what we need to find here is the set B intersection A complement union C. So now let's illustrate this information on the Venn diagram. So firstly, we're going to look for the most common element in all three sets, that is set A, set B, and set C. And when we look at our sets here, we're going to see that 4 is the most common element like we had in the previous example. So we're just going to write down 4 in the intersection of all three sets here, and then we're going to look for the most common element between the set A and the set B. If we look carefully here, it's only 4. And when we look at the sets A and C, the only element that is common in both sets is just the element 4, which we have already highlighted or included in our Venn diagram. Alright, so now let's look at the most common element between the set B and the set C. You see here that for sure, like we have in our Venn diagram here, set C is a subset of the set B. That means that all the elements that are in C are also in set B. We can see 4 in set B, we can see 6 in set B, and we can also see 8 in set B. Therefore, 4 is already here. We're just going to include 6 and 8 in the set C. That means that in the set B, we're going to remain with the elements 5, 7, and 10, which we're going to put in this area here. So we're going to have our 5 here, we're then going to have our 7 here, and then we're also going to have our 10 here. Basically, this is what we have for our set B. And then our set A, which elements are remaining? We can see that for set A, we have 0 here, we're also going to have 1, and then we're also going to have 2, and then we're also going to have 3. So the independent part of set A has 0, 1, 2, and 3. If we pay close attention, remember that our universal set has elements from 0 up to 10, and so far we've basically illustrated elements from 0 to 8 and the element 10 in the Venn diagram. We have not yet illustrated the element 9. So we're also going to have to include 9 in this Venn diagram, and it's going to come outside the three sets A, B, and C. So therefore our 9 is going to be here. So by doing this, we've basically illustrated all this information on our Venn diagram. Now let us find the set B intersection A complement union C. Like we did in the previous part, we're going to start with finding A complement. So A complement is everything that is not in the set A, and we can see here that A complement is going to be 5, 6, 7, 8, 9, 10. So 5, 6, 7, 8, 9, and 10 is our A complement. Now let us find A complement union C. What is our A complement union C? So our A complement union C, we're just combining everything in the set C with everything in the set A complement. So we're going to have 4, 5, 6, 7, 8, 9, and 10. This is our A complement union C. Now let us find the set B intersection A complement union C. What is common between the set B and the set A complement union C? If we pay close attention to the elements in A complement union C and the elements in the set B, we're going to see that 4 is common in both sets. 5 is also common in both sets. So we're going to have 5 here, and then 6 is also common in both sets. So we're going to have 6 there. How about 7? Yes, 7 is common in both sets, so we're going to have 7 there. 8 is 8 common? Yes, 8 is also common, so we're going to have 8 there. And is 10 common? 10 is definitely common, so we're going to include 10 in the set B intersection A complement union C. And this set is basically equals to the elements 4, 5, 6, 7, 8, 10. Now to prove that the area that we've shaded in our Venn diagram on top here, in our main Venn diagram on top here, we are going to have to shade the area that has the elements 4, 5, 6, 7, 8, 10 in the Venn diagram that we have below here. So when we shade this area, it's going to look something like this. Alright, so we have just completed shading the area that has the elements 4, 5, 6, 7, 8, and 10. And if we pay close attention, we'll see that this area that we have shaded here is basically the same as the area that we have shaded on our Venn diagram above here. That means that the area that we have shaded in our final Venn diagram above here represents the set B intersection A complement union C. Therefore, we have concluded and found the answers to all the parts on Roman numeral 1. Thank you very much, and see you in the next video.
Can you be my teacher? I'm gonna call me Lucha. Can you be